look around and stuff. This one is going to be about this Lasko window fan right here. And on the bottom back side it says it is a model W09550. It also says type WF9. That was on the backside bottle back, and this is the backside. And this is an add-in to the front of the Uncle Ron stuff about the window fan. And I just need to create a summary up front that's saying if it doesn't turn on, there's little or nothing you can do. There's no fuse in the plug itself. There is a fuse on the board, but it's soldered into the board, so you can't really replace it. And it's most likely the power supply section on the board that's inside that's supplying the logic board. So if it doesn't turn on, you can unplug it and leave it plugged back in for a while, but I don't think that'll cure it. There's not much you can do, unfortunately. It's a crime and shame to throw away such a good piece like that, but that's what happens. They added power supply on there so they could put all that logic, all those push buttons and that digital display. And that's what's failed. The rest of it is really straightforward. It switches voltage to the motors, turns the fan. Unfortunately, that logic board. Anyway, there's not much you can do with it. If you can replace a fuse on the board and that is your problem, then okay. Or if you can replace a capacitor on that board, then you could go ahead with it. Because in my case, it was the big capacitor associated with the power supply section that controls the logic board. This is an intro to Uncle Ron stuff. You don't have to watch the rest. If you got one and you don't know anything about the insides or how to do anything in the insides, if it doesn't come on and you're sure your outlet's good and you've done the right buttons, then it's just trash. Sorry to say that. Bye-bye. And I have taken it apart, and this is what it looks like on the inside. Why did Uncle Ron and stuff take it apart? Because it won't start. I had this in my garage. I'll pull it back away, whatever. You probably, if you have one of these, you'll recognize it because it looks identical to this, and there are panels that go out this way and this way that will let you fit it into a pretty normal window. And then it's fancy dancy up here. It does have a remote control, and you can also set the speed of the fans to 1, 2, 3. You can set the temp that the fans come on and go off at a set temperature. It's got a digital display here. I don't know. Anyway, I had this in my garage window for a while because my garage doesn't get a lot of cross ventilation, and I put one of the windows up. Didn't have a screen at the time, and I always get confused. And used it to blow air into the garage. It didn't work very well, but I used it anyway. Eventually I got screens in the garage and I didn't need this, and I set it aside, and probably been sitting there for 2 years. But I do clearly remember it working when I took it out of the window and laid it down to the side. And I have an issue with my downstairs. It's a basement with limited windows. It's hard to get, stale air down there. So I thought, well, I'd try this. I have it, and I try this and I have it, and I took it up and plugged it in, and nothing. So I hate throwing things away. If you watched any of my repair videos, I hate throwing things away. So I can't help myself. I gotta take it apart and see if I can figure out why and repair it. And the first thing I got was, I've already hooked on the cord. The first thing I looked at was, on the cord, it says that, here we go. It says that this device has some sort of protection. That little was down here at the end of this white section. There was a tag, and it said, this cord, this is protected some way. Okay. Well, sometimes these power cords have a built-in fuse right in the plug at the end. I looked at that, and there was no fuse in there. So, but I wasn't 1,000% sure, only 900 or 99% sure, so I cut that off, that plug off, and I wired on a new one, a longer one, temporarily. I replaced the plug on that end. I can make no assumption that there is not something wrong with the power cord. Okay. So I put this on, I tried again, nope. Alright, so that makes me take apart, take the back cover off, which is not difficult. However, it does have some screws. The heads I've never seen. It's a variation of Phillips, but only 3. And I luckily had a small enough flat blade to get them out. I was going to bring one down here, and I didn't do it. But every time I turn around, they're inventing some sort of new screw head, and I don't understand ever why. Anyway, I put on a new power cord. Didn't work. Took the cover off. Not hard to get into. And what I found is this setting, sort of like this. There is a plastic box that goes over this front panel, which is the button push LED display panel up here, and there's a plastic box fits over that, and then this guy fits over this hole and is held in place by 2 screws. And that basically is what it looks like when you open up the back and look at it. Okay, so I didn't find a fuse down in the plug, and it had a sign on it saying it was, protected. So I started looking up here. I took this board loose and pulled it out and started looking at it, and what I was able to find, and I will at least tell you about it if I can't show you, this guy. This is, if this is the front panel control board, the buttons push here, push little switches on this board, and over here, this guy is a little thermistor that senses temperature, because I told you this particular device will power on and power off if you set a certain temperature. The idea was you put it in your room at night. When the air gets down to 70 degrees, you'll let it turn off. That's how it works. And it senses that. So there is some logic up in here. This is a control board. And but you have 2 fans. You have to have power to control the fans, and also to power this logic board. Okay. Now we have 120 volts AC coming in the power cord. That's what you get out of a wall. And these fans are in fact 120 volt AC fans, and there are 3 speeds, which means they have multiple wires coming out of them. There's a common, and then I guess 2 others. 3 others? Probably 3 others. I haven't really looked that close at the wiring there yet on the fans, but probably. There's probably a white, an orange, yellow, and something else. But these are AC motors, and there's two of them. And the control board here, and then you have this board. Okay, you get 120 volts in. The control board and this stuff on the front doesn't run at 120 volts. Normally, computer logic could be 3 volts, 5 volts, 9 volts, DC, direct current, not alternating current like you get out of your plug. So on this board, there are actually three major sections. The first is converting 120 volts AC to some voltage, maybe 5, 7, 9, direct current, that powers this front panel button control board up front. Okay, and that the fact that I can't turn it on means I'm not getting, if there was 5 or 9 or 10 volts up here at the front, when I push that on button, it should have lit up. That's all a function of this control board up here. This board right here, all of it's doing for that control board at this point is providing power to it. So I don't have any power coming out of this section in my hand. It's not managing to perform the function of changing 120 volts AC to 5, 3, 9, whatever it is, direct current. Now, once upon a time, a long time ago, you had to use transformer to do power conversions. If you went from 120 to 30 volts, 49 volts, or whatever, you had a transformer involved there that stepped it down from 120 volts AC to, say, down to 9 volts AC. And then there was some logic, there was some circuitry which changed it to direct current. I'm not going to explain the difference between alternating current and direct current. They're different, they're not the same. This module up here, first thing it does is get direct current to provide that front panel control board. It's not doing that. Okay. So on this board, when I got to looking around, these things are UL approved, United Underwriters Laboratory. It has to be protected in some way. Remember, the cord said it was. Wasn't a fuse in the cord. So I come up here and start looking around this board, and sure enough, it's actually, let's see, over here on this side, I believe. But there is a fuse soldered to this board. Yep. It's a little teeny black component right there with my thumb on it. And it says fuse. Now, it doesn't look like a fuse you've ever seen, and this one's totally enclosed. You wouldn't be able to look at it and know it's blown. There is a fuse. If I said Underwriters Laboratory to get a certification on this kind of device, it has to have the fuse. It does. They put it right there on the circuit board. But apparently, in their wisdom, Underwriters Laboratory did not insist that it be user replaceable. Used to be on the back of things there was a fuse, a little thing, and you could untwist it, pull it out, and there was a fuse. You could put a new fuse in it, twist it back in, and you're off to go. Well, on devices like this, apparently it's not required. So in this case, yeah, that's protected according to, it has to be, according to law. If it pulls too much current, things start getting hot, it blows that fuse, and this thing is dead. It's got a fuse in it. It's not user replaceable. I mean, so this whole thing goes to trash as soon as you blow that fuse that's on the board. That could be your problem. I took a volt ohm meter and checked, and that fuse is okay for me. That is not my problem. The fuse is there, it was making connection. And the fuse comes up, it takes one line of the power cord. It is attached to one line, it goes through that fuse and then on to the rest of the board. So if that fuse blows, 120 volts really isn't at present at this board anymore, so the fuse has got to work. and in this case it does. So something else is at fault here. And when I look around, again, I told you once upon a time they use transformers to move from 120 down to, let's say, 9 volts AC. They did that first reduction using that. They don't do that anymore. When they came out with transistors and were able to make transistors and then other semiconductor-based devices. Some of the devices on here, and I'll put my finger on one. This guy, you can't see it very well right here, but it has a metal lug on it. There you go, you can see that metal lug. This guy is taking in heavy voltage and chopping it in two. It's like it's chopping the highs or giving you only half of the 120 volt cycle. And it uses some of those, and by trickery, if you will, it reduces it down to 9 volts direct current. And part of any of those circuits are these black cans that you see here. There's one there and one there. And then there's a great big one right there. And that sets on the power circuit. And when I first looked at it, I said, that's the problem. Because what happens is these things go bad and the top starts bulging in one eye. You can't see it, but this one was bulging. That is, I suspect, 99%. That's my problem, is a bad capacitor right here. And capacitors seem like they're the major failing item on any sort of electronic circuit. Now, I'm an electrical engineer by training, but circuitry is not my forte. I'm more of a computer or software logic guy. But anyway, I know enough to understand how this particular board works, and I suspect that thing has failed, and therefore I'm not getting the direct current I need to control the front panel, and that's the reason it will not come on. The logic's not being powered. Okay, what else is on this board? Two other things. The 9 volt control panel up front cannot directly control these fans. So on this board there are a set of two right here, these black boxes. These are relays, and they probably use 9 volts input. So when a control board says, oh, we need to power up the fans, it provides power to this relay, which basically closes a set of contacts. Those contacts are 120 volt AC, which go to the fan. And by using which wire goes out there, you determine what speed. But there are relays here, and that's basically where you can use a small voltage to control higher voltage. So that's what these are. The control panel sends 9 volts DC to these relays. The relay closes, the fan spins. Okay. The other thing on this board is, over here are these blue guys. On AC motors, you have what's called a run capacitor. And I won't get into the exotics of that, but AC motors require what's known as a run capacitor. And it delays, current goes through these things, and it delays, if you will, the shape, the timing of the alternating 120 volt AC. And it helps these guys get started to continue to run. These guys require it. So I have the black hands, which are relays, which just simply is a switch. It's an electrically controlled switch. Instead of flipping it with your finger, the control board says close or open. Let off the current, let off voltage, and the contacts open up. The light goes out. The fan stops turning. The blue boxes are required for AC fans to start up and continue to run properly, primarily in the startup phase, but they're known as run capacitors. Once upon a time, they're called startup, and some AC fans may require both. I'm not 100% sure on that. Okay, so that's my diagnosis of the problem, if you will. I have Fuse on the board, it's not blown. I have taken and I thought, well, here is a connection coming off that power cord, and it's been crimped right here, and I thought, well, maybe it has a thermal protector in it. Some devices like this not only have a fuse, which is on the board here, but they also have what's known as a thermal cutoff switch. So if it gets too hot, that will cut out and the whole thing is dead. In some cases, the thermal cutoff will cool off, reset itself, and you're back alive again. In other cases, it's a one-shot. If it gets too hot, that thermal cutoff opens up, the thing is dead, and the only way to fix it is to replace that thermal cutoff switch. So I wasn't sure if there wasn't a thermal cutoff switch right here in this junction where the line power comes in from the power cord and then goes on. Actually, in this case, it's interesting because it goes right over to one of the motors. Okay. I opened this up enough. No, there's no thermal in here. And then I used the voltmeter and I said, okay, well, let me make sure I'm getting power to my cord, because power comes up and it does go, and it's soldered to the back of this board, and the fuse, and blah, blah, blah. And I measured, I am getting 120 volts AC at this point and at the board. Okay. Alright. I got a bad capacitor. I'm pretty sure of that. I don't see any trauma or evidence of any components burning. The resistor, that big one right here, is in the power circuit, of course, because it's huge. Same way as that capacitor, which I showed you, the great big one, the can that's bulged out at the top. What am I going to do about this? I don't want to throw this all away. It's got two perfectly good 120 volt AC motors on it. I'm still looking for a way to set this in my window and blow air. Do I need all the fancy smancy temperature controlled 3-speed digital display? I don't know what else is even up there. Do I need that? No, I really don't. I just want the fans to turn. So I am thinking about carrying a bunch of this stuff out, taking this control board off the front, discarding that, or adding it to a pile of electronics. And from here, I am going to save the running capacitors. I do need those. If I save those, then I can rewire. I've got the wires coming from the fans. I have the running capacitors. All I need then is a switch. I could put a fuse in the circuit as well, but that's all I need. I flip a switch, power is applied to the run capacitor, which then is tied to the fans, and the fans come on and run. No relay required. The switch will be for 120 volts, directly setting on the power cord, and through the run capacitors. That eliminates the logic board, eliminate the conversion of 120 volts down to 9 volts or 5 volts or whatever it is. I just power up the fan. In fact, I don't even need a switch, really. I mean, yeah, I should have a switch, but I could wire it directly, so fans only run when I plug in the cord, pull out the cord, or so on. I do not want to throw away this whole thing. All I really want is the fans to work. That's the goal. I want the fans to work. Do I need all the fancy stuff in the front? No, I don't. Yeah, it was designed in this, but in the end, to get this control logic, I had to put a power conversion circuitry on this board, which has failed. And my wife asked me, what's the cost of that component right there that failed? You think that's a bad one? I could go that route. Probably 59 cents. And these fail all the time, and I can get one. I might have to spend $3, I know, with shipping or whatever, but it isn't anything. And this one's pretty big in the circuit. I could probably replace it. I'm not 100% sure that's totally the problem. It could be one of these other power conversion devices that are on here, or maybe another capacitor. I don't see any trauma. I don't think anything. The only thing that was obvious to me was this bulging black capacitor right here. Okay, so that's all I got to say about this. If you have one of these and it will not turn on, it's interesting that if you check the troubleshooting site related to the Lasko, not Fasco, it's a different company, Lasko, it says there can be some delay when you start up the device. I take that to mean you push the button, the red light comes on, says it's on, it might be delayed before the fan starts going. Okay, I can buy that. But there should be no delay when you hit that on button. No. I did think, and I did contemplate it, well, maybe it has a battery on this board somewhere to keep this logic light if you unplug it. Some things have that, usually they don't. For instance, I have a generator stove and has a digital clock on the front. If you turn off the circuit breaker to the stove, you got to reset the clock. There is no battery in the panel to keep the clock alive when you remove the power. I suspect that was true here as well. If you remove the power, you're going to have to refresh all your settings on the front. But it was possible that they did put a battery on it. And one device here looks suspiciously like a battery to me. And I haven't torn it apart yet. I probably will. But there is a device right over here near the fuse that is blue, which looks very similar to a soldered on small 3-volt battery, whatever. And the purpose of that is to keep the logic alive on this board, which may have some memory in it as to its previous settings. So if you unplugged it, you then plug it back in. These settings here on temperature and what fan speed you had would all still be stored in a little teeny bit of memory that is on this logic board. But I'm not going to futz with it. With the run capacitors, which I can remove or cut the board and take them off and keep that portion, a switch or no switch, a fuse added or no fuse added, I can get the fans to run again. That's all I'm interested in. So this was a Lasko. And I hate to say it, but, I hate to throw away things like this. And I wish UL would require a fuse cartridge on the back of the device that a user can get to and easily place the fuse. At a minimum, that's not asking too much. It couldn't cost too much to design into the circuit. You put it out here instead of on the circuit board. How many people are going to tear this apart and actually realize that the fuse is just blown, lightning hit nearby, and this thing's on and pop the fuse. Now you got to replace it. You don't know you got to replace it. But that's all that's wrong with it. Now it goes to the landfill, and it lays in there for 1,000 years. And in the year 20,000 or something, when we're mining landfills, they'll probably come across thousands of these things laying in the landfill, because as homeowner, you don't know what to do with it. It doesn't come on. And destroy it. You buy a replacement. I should not have. I think it was only available to me. I've seen a video where somebody tried to repair one of these, where all this fancy logic wasn't here. It was more just a switch. And that must have been a real early version of this particular configuration, because it looked similar about it. It had these screens, it had these two fans, but this panel did not have a remote control eyeball right here. And you didn't have all this. It may have had one knob that says speed, 1, 2, 3, another one said on. That would be much easier to repair. I should not have had a logic board out here on the back side, which is the button logic board. Again, 3 functions on this board: converge from 120 volts down to whatever power is being used by the control board. a set of relays, which the control board can control with 5, 8, 9, 10, 3 volts direct current, and the required 1 capacitors for the 2 fans. And that's it. That's all enough for today. Too long again, but maybe you got something out of the whole. And you find out all the time is there has to be a power conversion done to control any sort of logic like you see on the front. Control boards, that's digital logic. It doesn't run 120 volts AC. It just doesn't. It's meant for 5, 8, 10, 7, whatever volts. Computers might run 13, I don't know, but it's direct current and it's Uncle Ron's stuff. This was about the Lasko super duper model right here on the bottom, right there. This is the model W09550, made in China. Lasko window fan, and that's it for today on this. And I don't know if I will come back on another video and show what I did or not. I am definitely not going to just take it to the landfill. I will at least tear out the logic board and get those wires that come off of the fans and the run capacitors, and I'll just go from there. I may put a fuse on the circuit, I may put a switch on the circuit, may not. All I want is the fans to turn when I want them to. Uncle Ron's stuff today is the 20th of June, 2024. I hope you have a good weekend. It's coming up on the weekend. Bye-bye for now.